Ladies and gentlemen, welcome to video 18 in a series of video lectures that are companions to the book The Fivefold Sun, which was filed in late 2017 at the Bibliothèque Nationale de France in Paris. We are now on November 26 in the year 2018, about a year later, and we will address today in part 4 of the book The Fivefold Sun the issue of the relationship between solar cycle length, amplitude of the cycle, and partition of the solar ball. In video 18 we start with an enigma and we end with a conjecture. The enigma is the breadth of the solar cycle's length. It reaches from 8 years to about 13 years, as found by Schuster in 1906, the man who invented the periodogram and tested it on the solar cycle. Why as short as 10 years? Why as long as 13 years? What is the physics or the basic laws that underpin such limits? Then we have an accepted rule, which is the dependence of activity amplitude on solar cycle length. The longer the cycle, the weaker. From this rule or principle, we can try to derive some further insight into the workings of the solar ball. In part 4 of the book, The Fivefold Sun was found, as reported in the previous video, that while there are 144 rigid rotations in a standard central value Schwabe cycle, for the observed long cycles in the long bin cycle range, as suggested in the previous video, the number of rigid rotations is about 169, and in the short bin it would be around 121. So in all three cases we would have square numbers of respectively, for the standard value, 12 balls, 12 interpreted as a number of balls partitioning the solar sphere, as introduced here in part 2, and then by analogy 13 balls for the long cycles and only 11 balls for the short cycles. But are there any longer cycles than 169 rotations and any shorter cycles than 121, even though none of these were actually observed after 1700 AD. We first search for a higher upper bound, if any, and we can use the millennial radionuclide records for proxies. These will be relevant for lengths of more than the solar cycle length standard value. What is found in the Fivefold Sun as a book is that there are indications in the radiocarbon record and in the beryllium record that there are solar cycles of about 13.25 years length that have existed in the distant past. These were also found in some harmonic analysis of the sunspot record itself, especially in the early years. Again, Schuster 1906, 13.75 years. Then there are cycles of 14 years that are suggested, although not observed and also not found in the radionuclide millennial record, for the deep minimum episodes in solar activity. In the radiocarbon record, this would be the case for the Maunder minimum from 1645 to 1715, for instance. So we can propose a extension of the rule of dependence on solar cycle length for the amplitude of a sunspot cycle and set a limit of about a threshold of about 13 years for the effectiveness of a solar cycle in terms of actually producing sunspots and such other tracers that mark solar activity. This was first proposed by Serre and Nem-Rib in 2000, based on their analysis of the Maunder minimum. Now we turn to the lower bound, for which radionuclides will not be helpful because their resolution is low for values lower than the solar cycle length. But we can turn to some periodograms and spectral analysis for which the procedures allow to fetch in the spectra maximum to maximum periodicities as opposed to minimum cycles, as was so far investigated in this work. And we find that the maximum to maximum periodicities include some extreme intervals, extremely short intervals. There is in the literature a number of findings of a length of 8.3 years or 8.4 years in the sunspot record. This is an excerpt from a table in the Fivefold Sun as a book, in which you see on this column these results, which are around 8 years for a period in the spectrum of the sunspot, relative sunspot number time series or a similar time series. And this length corresponds also from inspection of the individual Schwabe cycles to the shortest observed cycle length, which are counted, which are measured from maximum epoch to maximum epoch. But we have very high uncertainties as for the actual true epoch of such maxima. We have perhaps here ground to invoke a new notion of hyper-short cycles. The hyper-short cycles of a length of slightly less than 8 years would be, for instance, the 2 cycles that are proposed by several authors to split the cycle number 4. There are also from maximum to maximum 2 actually observed cycles. And these hyper-short cycles would represent the lower absolute bound for the effectiveness of a solar cycle. The dependence of amplitude on length would imply that they have a very high amplitude, so high that they in fact split in 2 cycles. We can now propose a general picture for the bounds of quasi-decadal solar cycles at which they become ineffective by lack of activity or by excess activity. And you see in the hyper-long pulses, this is 14 years. In the hyper-short pulses, this would be 7.7 years. And the numbers of rigid rotations would be respectively 190 and 105 or so. So if we now translate this number of rotations into a square and find its root, again, as in the case of the long bin with 169 rotations and the short bin with 121 rotations for actually observed minimum to minimum cycles. Now, for maximum to maximum cycles in the millennial record and in periodograms, we find a number of 14 for the root of the number of rotation and a number of 10 for respectively the hyper-long and hyper-short cycles, which would correspond in fact to a threshold for the presence of a cycle or not. This is now, ladies and gentlemen, the end of video 18. In the next video, we will address the issue of the detailed geometries that may be underpinning the several characteristic solar cycle lengths and their probabilities, how they occur in sequence, how they might be superposed, how they might be synchronized. I thank you for your attention.